Hi friends, it's Emily from Suffolk Public Library. Today we're going to be doing some science experiments that you can do at home. Now our first activity is called Magic Milk. More than likely you already have these materials at home. The materials that we will be needing is whole milk, Q-tips, Dawn soap, food dye, and please avoid gel if possible, and then a tray or a shallow bowl. I have all my materials ready and let's get started. First, we're going to take our bowl and we're going to add just a bit of our whole milk, enough to really cover the bottom of our bowl. Next, we're going to add some drops of food dye. Now, I picked a couple colors. You can pick 2 at least, or do all of them. But today I will be doing just 3 colors. So I'm going to use my yellow and do at least 3 drops of that. I'm going to use my green right in the middle. And then I'm going to add a couple blue drops. Now the placement really doesn't matter. Just make sure that you're spreading them out from one another for a cooler effect. Next, we're going to get our Q-tip. And we want to dip it in the Dawn soap. So we want to make sure that we're really coating this Q-tip. We want it to be blue when we're done. Let's get started. We're going to poke our milk and see what happens next. Whoa. Check out that movement. It almost looks like tie-dye, right? Or fireworks. So if you look really close, you'll start seeing these little balls run across the surface. These are called spherical micelles. So why does this work? What is the science behind this activity? Well, milk is made up of minerals, proteins, and fats. So proteins and fats are susceptible to change. So when the dish soap is added to the milk, the soap molecules run away and they try to attach to the fat molecules in the milk. So the movement disrupts the surface tension of the milk and pushes that food coloring all around. That's why the food coloring kind of looks like fireworks, because it's getting bumped around and causing an explosion. So the soap breaks the surface tension of the milk, and when the soap molecules head for those fats, they form that spherical micelle. This causes movement and creates those cool bursts of colors and the swirls. But after the fat molecules have been found and equilibrium has been reached, there will be no more movement. This is a cool and easy activity that you could do over and over again. Just make sure that you get some new milk. I hope you like this one. Our next activity will be doing something called a fizzing rainbow. So the materials you'll need is a cup, any size, but small cups that are possibly disposable definitely work best. You'll need baking soda, vinegar, food coloring, and please use liquid. They also work the best. And a baking sheet or a tray. So I have gone ahead and pre-filled my cups with each color. So I've got a blue one, I've got a yellow one, we've got green, and we've got red. I've mixed in that food dye, and I've also gotten an additional cup, and I filled it up with our vinegar right here. And we're gonna see what happens when we go ahead and pour this vinegar right into our cups. Now, are you guys ready? Let's get started. Whoa. How beautiful is that? Now you can keep pouring vinegar. There's a lot of baking soda in there. And you can keep doing this until there is no more vinegar or no more baking soda left. How cool is that? So let's talk about what is the science behind this activity. So not only is this experiment really fun and pretty to watch, but it also teaches us about chemical reactions and how different substances interact with one another. So the baking soda and the acid in the vinegar reacts when they interact with each other by trapping carbon dioxide, and then that forms the bubbles that we see. The mix creates a liquid and a gas, which turns into that foam. Another fun way you can do this activity is to, instead, if you don't have paper cups or small cups, you can fill your entire tray with baking soda. And then if you have little medicine droppers that you may use, you can fill those medicine droppers with the vinegar. And you can take your food dye and drop little drops across your baking soda on your tray and basically make the whole entire tray a bubbly, exciting event. I hope you guys enjoyed this one. The next activity is making Oobleck. This was a really popular activity, and it only takes a few materials. So the materials that you'll need is cornstarch, water, a bowl, food coloring, and even a measuring cup. And don't forget the spoon. I've got my materials set up, and I have went ahead and pre-measured 2 cups of cornstarch into our bowl. The next thing that we're going to do is take our 1 cup and we're going to pour some water into it. We just need 1 cup of water, and we have to slowly add this. So I'm going to be using my spoon and slowly adding a little bit of water in at a time and mixing that in. Now we also have some food dye. So before this gets too thick, I'm going to add some green. So it doesn't matter how many drops you put in. You can add a little bit or a lot. I'm going to mix that in. And as we start mixing, you'll notice that you feel these hard clumps. And that's okay. That is absolutely supposed to happen. And when you get a lot of that water in, it's going to start to kind of get heavy. Now it is optional, but you can get your hands in there. And sometimes using your hands helps. You can see these large clumps starting to stick together. And it's getting a little hard to mix. So pretty soon I will be going in with my hands. I'm going to go ahead and add the rest. And you see that water's just kind of sitting on the top. It's getting a little bit harder to mix in. So I'm going to go ahead and use my hands. I will warn you, this is a very messy activity. Now let's get our hands in. Get you a close up. Now it's starting to kind of stick. It's liquidy, but it's also kind of heavy, like a solid at the bottom. You can see that. So I want to make sure that I'm getting all of those clumps mixed in with the water. So I'm scraping the bottom. And you see how that pour is? Whoa. Looks kind of gross, kind of slimy. So let's talk about the science behind this. So why does it act that way? Well, Oobleck is a non-Newton fluid. That means that its velocity and thickness changes based on stress or pressure. So it almost interacts like a solid state. And that's only because under pressure, with squeezing, The cornstarch particles jam together and trapping the water, acting as if it's a solid. But when it's a liquid state, without the pressure, the water acts like a lubricant, allowing particles to slide past another and make it kind of flow. I have let my Oobleck sit a little bit. If you find that your Oobleck is more water than it is solid, feel free to add some more cornstarch to it. I also want to advise you guys that Oobleck should be stored in an airtight container at room temperature for maximum 24 hours. Beyond that, it may start to grow bacteria and mold, and we don't really want that. Also, please do not eat Oobleck and make sure that you have parental supervision when you're doing this activity. I hope you guys enjoyed this. Our next activity is called at-home lava lamps. The materials that you will need is a clear jar or a clear water bottle, vegetable oil, water, food coloring, anti-acid tablets, specifically Alka-Seltzer because Tums will not work, and a flashlight. And if you're feeling special, you can add a little bit of glitter. So we're going to go ahead and get started. What we want to do is take our water bottle, and first we want to fill it 1/4 of the way or 1/3 away with water. So we're going to go ahead and slowly pour in our water, about 1/3, 1/4 of the way. And then we're going to add our vegetable oil. So we're going to add this about 3/4 of the way, and we'll start to see that the oil will separate directly from the water. It'll create two distinct layers because water is denser than oil. So next we're going to take our food coloring. I'm going to use the color blue. And we're going to do 5 to 10 drops. These drops will pass through the oil and mix with the water at the bottom. And we can see that they are separate. Next is the fun part. So we're going to take our Alka-Seltzer. I have already broken one up into pieces. And we're going to drop these pieces into our jar. And we're going to watch what happens. You guys see that movement? It looks just like a real lava lamp. And the cool part about this is you can do it over and over and over again. How exciting is that? So let's find out why this happens. What is the science in this? So the oil will float to the top because water is less. So let's talk about the science behind what's happening. The oil floats on top of the water because it's less dense and lighter than water. So the food coloring has the same exact density as the water. So it's going to sink to the bottom and go through that oil and mix with the water. So when you add the tablets, it sinks to the bottom and then it starts to dissolve. So as it's dissolving, it makes a gas called carbon dioxide. Gas, or the air, is lighter than water, so it floats to the top. The air bubbles bring some of the colored water to the top. And then when the air comes out of the colored water blob, the water gets heavy again and it sinks. And it does this over and over and over again until the tablet is completely dissolved. And as we see, our tablet is completely dissolved and our little reaction has stopped. And for safety tips, please do not put the top on the bottle while you're doing this activity. It is not safe, and always make sure that you have an adult present for this experiment. I hope you guys enjoyed this, and thanks for watching Science at Home. So towards the end of our original materials, we talked about needing a light and some glitter if you want to get fancy. I have already added some glitter to my water bottle, and I'm going to be using my phone for the flashlight. So carefully place your water bottle over top of your flashlight. And it's already kind of looking like a lava lamp, right? Nice and shiny. So we're going to take the last bit of our Alka-Seltzer and we're going to drop it in again, just like we did earlier. But now we get the full lava lamp experience. How cool is that? That way you can really see the movement. And remember, once the reaction is done, if you have leftover Alka-Seltzer, you can do this again and again and again. I hope you guys enjoyed this.